All right, mathletes, here we are looking at problem solving with trigonometry. So as you're problem solving with trigonometry, some things you want to remember is always to remember to write and draw a diagram. Okay. One thing, diagram, try and label your unknowns. Typically use x for lengths, okay, and theta for angles. Locate your right angle of a triangle so that you can utilize your trigonometry. Write your equation connecting the angles in two sides with the appropriate trig ratios. Solve out and write your answer in sentence form. And remember, units are important as well. All right, so let's look at some other resources we have for problem solving. So things to remember. We're always trying to look for right triangles. So sometimes we might not have the original shape being a right triangle. But we want to recognize that for an isosceles triangle, can be made up of two congruent right triangles that are just reflected over this dashed line. Okay, a rectangle again can be made when you draw a diagonal across. You create your two right triangles. Again, those two triangles are congruent as well. A rhombus, okay, can be made up of four congruent right triangles. Notice all of the x's are representing angles of that same length and the dots representing those same lengths. So we get four congruent triangles here. Also, what's important to remember is that the diagonals bisect each other. So as this diagonal is here and it's cut by this diagonal, they cut them in half. So you always know that those four triangles are congruent. Kites are made of two different congruent triangles. Again, it's a reflection across this dotted line here, where we can see triangle 1 here. This right triangle is congruent to triangle 2. And we can write that out. Triangle 1 is congruent to triangle 2. And then we have triangle 3 and 4. And triangle 3 is congruent to triangle 4. And our right angles right during those at that intersection of those diagonals. Okay. All right, let's look at an example here. So, an A-frame house has the shape of an isosceles triangle. The isosceles triangle with a base angle of 70 degrees. So a base angle is always in conjunction with the congruent sides for an isosceles triangle. So if that's 70, we also know that this angle is 70 as well. Okay, the oblique walls of the building are 12 meters long. Okay, how wide is a building to the ground? So if I think about this shape, again, I know I have two right triangles here. So I'm going to redraw just one of them. And since I want to find how wide is a building at ground level, that's here, okay, I'm going to call this x and know that my width is going to end up being 2x because I double my triangle. My right angle's here. My 70 degrees is here. Okay, and I know that this is 12 meters there. All right, so in order to solve for my x, I identify the sides of my unknown, which is going to be adjacent to my 70 degrees, and my 12 is my hypotenuse. So what trig function? So again, I'm always going to write this on the top of my paper so I can remember which trig functions deals with adjacent and hypotenuse. Well, that's cosine. So I'm going to set up my equation. Cosine of my angle is equal to my ratios. So that's my unknown a. Well, let's just write that actually as x over our hypotenuse, which is 12. Putting this over 1 and cross multiplying, I see that 12 times the cosine of 70 degrees is equal to x. I use my calculator and input that in, and I will see that x is equal to 4.1. Okay, and since I'm trying to find my width, I'm going to remember that I need to double that to find the total width across. So 2 times 4.1 is going to be 8.2. 2. And again, I'm going to remember it, my units. So 8.2 meters. Okay. Another example here. For this example, we're looking for a ramp. Okay. So a staircase 3.6 meters in length is needed to access a platform 2.9 meters above the ground. Find using trigonometry the angle the staircase makes with the ground and the distance from the foot of the staircase to the post supporting the platform. Okay, so I'm going to redraw my picture here, labeling the importance here. So this post is going to make a right angle here. You can see from my diagram here that the staircase is 3.6 meters in length. Okay, and the platform, it has to get to a height of 2.9. Okay, so my first part is I want to find out the angle the staircase makes with the ground. So the ground is there in the staircase, so that's my unknown theta. Setting up my equation to solve for this, and again, this is just part A, I'm going to recognize that I have a opposite side and a hypotenuse, and I'm finding an angle. So opposite and hypotenuse is going to be sine. But because I'm finding an angle, I want to do the inverse sine. So inverse of my ratios of 2.9 over 3.6 is going to be equal to my theta. Using my calculator, I'm hitting second sine, and I get 2.9 divided by 3.6, and I get 53.7 degrees is my angle that it makes with the staircase. Part B, okay, I'm going to use the same diagram. I want to find the distance from the foot of the staircase to the post supporting the platform. Okay, so to find that, that's right here. So I could use, now that I have an angle, I could use trigonometry to do that. But in case that maybe I made a mistake here, I always like to use the given information. So since I have a right triangle, I'm given this length, and I'm given this length, I can use Pythagorean theorem. So I get x squared plus 2.9 squared equals my hypotenuse squared. I rearrange this, and I see that x squared is equal to 3.6 squared minus 2.9 squared. And then I'm going to take the square root of all that. So I get x equals the square root of 3.6 squared minus 2.9 squared. So it's my calculator, type it in, and I get a solution of 2.13. Remembering my units, we're dealing with meters. Okay, so that's going to conclude our notes tonight. If you have any questions, make sure you highlight them and bring them to class tomorrow.